Hello my dear students, welcome back to the lecture. In this lecture, we will see how a practically centerline marking has to be done. We'll break this lecture into two parts. In this lecture, we'll try to see, and even in the next lecture, we'll try to understand the remaining part. So straight away, first I'll explain you with the help of a structural drawing, and then we'll look into the practical video of this. So this is that drawing what I have, and for the same drawing, the centerline marking has been done. First we'll try to understand. It will take some 5 to 10 minutes in the beginning, and then we'll straight away get into the video of this. So we know all these things, right? This A, B, C, D, these are the vertical grid lines, and this 1, 2, 3, 4, 5, 6, these are my horizontal grid lines. So whatever grid lines you are able to see it here, the same grid lines we are supposed to do it on the ground, right? That's the first thing. Now practically how they do it, let me give you an example for that. So usually in the real field, what they do is, wherever we have these grid lines, right, we are going to keep the stones over there. That stone can be a laterite stone or whatever stone. Okay, so I am keeping one stone here. You can see one more stone here. I mean, you can see the grid number 2, isn't it? You have to keep on both the side. Okay, so I'll keep it here. Then again you can see 3 number here. I'm going to keep one more stone here. 4, I'm going to keep one more stone. 5 grid line, I'm going to keep it here. And 6. Okay, on one side it is done. Now the question may come, how do they try to keep this center to center distance? Now whenever they put this stone, right, over that, they are going to keep they are going to hit a nail over this. I'll show you practically. You have to take a nail and you have to hit it. You have to hit the nail on this stone, and once you hit the nail, then with the help of a tape, what we can do, with the help of a tape, we can measure that distance, right? That is, you can see from here, from this center, okay, to this center, what is the distance given here? It is mentioned you have to keep 17 feet 4.5 inch. You can see it here. In the same way, if I go to the next one, see here, from this center to this center, what is mentioned? It is 4 feet 9 inch. It has to be 4 feet 9 inch. You can see 4 feet 9 inch here. And from this center to this center, it has to be 5 feet 1 inch. From this center to this center, it has to be 4 feet half inch. And from this center to this center, so what is mentioned here? It is mentioned 16 feet 0 inch, isn't it? So it's mentioned here 16 feet 10.5 inch, right? You got it? So in this way you're supposed to do it. Now I've explained you on the one side, isn't it? So we'll do the same stone marking on the other side as well. Quickly we'll try to do that. Now again I'm going to keep my stone even on this side. Again I have a grid here. Okay, I have a grid here, here and here, right? So one horizontal side we have done. In the same way, let me do it on the vertical side as well. Now for the vertical side, this is my A grid, isn't it? I'll keep one stone here. This is B grid. Again you can see the center to center spacing there, isn't it? So it is 4 feet half inch. This is 5 feet 8 inch. This is 4 feet 0.5 inch. And from here to here it is 14 feet 6 inch. So one side I have done. On the same, in the same way I have to do it on the other side as well. So I'm doing the same thing. Again this center to center distance is 5 feet 8 inch. This is 4 feet half inch. Okay, this is 14 feet 6 inch. Is it understood? So up to here you are supposed to do it. Next, we know that, like I mentioned, we have to nail it here, isn't it? I told you that we have to put a nail here, right? In this way we are going to nail it. We are going to nail it here. Okay, we'll nail it here. Similarly here also we are going to nail it. Here also we are going to nail it. So once that is done, next what we are supposed to do, we are going to take a thread. Okay, we in local language we call it as line dori, and then you are supposed to tie it from this nail to this nail. You try to tie it, so that will be your center line. If I do it exactly from this center to this center, you can see this dotted line. It's the same marking what you are supposed to do on the ground. Again from this nail, this center line, you can see the dotted one. So this is the center line, it's meeting here. Similarly this center line is meeting here, isn't it? Similarly this center line is meeting here. You have to do that again from here to here, again finally from here to here. So one side I have done. I'll do the same thing on the other side as well. Again from this center line to this center line. So I'm going to tie the thread on either side, and this is how my all the center line will be prepared. Got it? So this is how your center line you are supposed to prepare. So once this is done, all the alignment will be done. Next, what we are supposed to do, you can see the footing here, isn't it? You can see the footing here. See, this is the size of the footing what they have mentioned. So whatever is the size of the footing, you have to do it practically on the side. Now from this center line on this side, what is the distance it is mentioned here? If you can observe it here, just pay attention. So you can see something written here. It is written 3 feet and half inch. From this center to this side, it is 3 feet half inch, and from this center to this center, it is 3 feet 10 and a half inch. What is supposed to do? From this center to here, you have to mark 3 feet half 1.5 inch. From this center to here, you have to mark 3 feet 10 and a half inch. In the same way, from this center to this outer, you have to mark 4 feet 1.5 inch. This distance is not mentioned, but from 6 feet overall, the size of the footing is 6 feet on this side. So if you deduct 4 feet 1.5 inch, this much whatever is the distance left, now you are supposed to get it, right? Now I didn't explain about the working space. We'll try to see the working space and all later. Along with this, what you're supposed to do as an engineer, site engineer, you have to apply one particular rule that is called as 3-4-5 method. So what is that 3-4-5 method? Let me explain it here once, and then we'll see the same thing happening on the ground. So in 3-4-5 method, you will measure, on the 3-4-5 method, you'll measure from here 3 meter, okay, whatever it can be, 3 meter or 30, what we'll consider 3 meter. From here you are going to measure 4 meter, okay. Now what I need to do, I need to make sure when I check the diagonal, that is, this is a diagonal, isn't it? For this particular triangle, this becomes my diagonal. So, and if I write it here again, if this is my 3 meter and if this is my 4 meter, sorry, if this is my 4 meter, my diagonal should be 5 meter. How is this 5 meter? Simple, we know Pythagoras theorem. The Pythagoras theorem, if I do it here for the Pythagoras theorem, so let us say this is that, okay, and then this is that other one, and we'll see, so this is how it is. So what the Pythagoras theorem says that, so if I give a name to put it in a very better way, let me give this as A. We all studied all this during our school days, isn't it? This is A, we'll say this is this as B, and this particular point as C. So the Pythagoras theorem says that whatever is your distance, whatever is your distance, the square of this distance plus the square of this distance should be equal to this, isn't it? That's it. So if this is 3 meter, if this is 3 meter, and if this is 4 meter, then obviously this will be 5 meter. How is that? So simple. What is 3 square? AB square. If I want to write, I'll write in this way: AB square plus BC square. This has to be equal to AC, okay. So that means what is AB square? AB square is 3 square, so I'll write 3 into 3, plus what is BC square? So it is 4 into 4. So what is the answer for this? 3 plus 3, it is 9, and I'll write 9, and 4 plus 4 is 16. So if I add this, you are going to get 25. And whatever is the square, now the answer is that AC, it is the square root of AC, okay. So I'll write in this way, square root of AC. So what is square root of 25? If I write what is under, square root in the sense under root of 25 is equal to 5. So that is how I should get the answer. This answer should be 5, right? I hope your fundamentals are clear up to here, and whatever I explained here, right, the same thing we'll see through with the help of a practical video, right? I'll play a video and just observe it. First what these people will do, these people are going to keep the stones like I mentioned. You can see one stone being kept here. So in this way you need 3-4 people to do this activity, and then he is going to nail it, okay. You can nail it anyway, provided when you keep it, make center to center distance between the nail according to the structural drawing what is given to you. So we'll put a tape to that, and from here we'll measure it. Okay, I'll try to go a bit forward. So you have to measure this distance. Okay, first we'll see what is the distance we are getting, and then practically we'll see what we are supposed to get from the structural drawing. So what you can see, then it is written 32 feet. If you observe it, let me show it once again. So what is written? It is 32 feet, isn't it? Did you observe that? I'll go a bit backward. Yeah, so you can see it's 32 feet, isn't it? Now we'll go back to the structural drawing where this guy is actually doing the work. Is you can see from here, see here, from this outer of the footing to this outer of the footing. Okay, what is mentioned here in the structural drawing? 32 feet. So that outer to outer he has given. Okay, you can do it from grid to grid. Okay, this guy has done from outer to outer, but usual practice is we will do it from grid to grid. Okay, that is how we are supposed to do it. Okay, yeah. Now whatever distance he is measuring, right, this distance, so this is this particular distance, he is going in this direction. Now he is going in this direction, that is from here. Okay, this overall distance is 58 feet 6 inch, but that is from outer to outer. He has to take it from this center to this center. So if you're not able to understand, see, this distance is outer to outer and it is 58 feet 6 inch, but we are supposed to do the marking from the center to this center. Then what you are supposed to do, whatever is that particular offset you have, that is 5 feet 7.5 inch from here. Okay, and 4 feet 9 inch from here, you take it out. That is 5 plus 4 is 9 feet, isn't it? 5 feet from here, 5 feet from here, 4 feet from here is 9 feet is out, and in 9 feet again this 9 inch plus 7.5 inch, almost you have to deduct 10 feet, somewhere rough to 10 feet 5 inches. Let we consider, that means out of this 58 feet 6 inch, 58 feet 6 inch, you have to deduct roughly around 10 feet 6 inch. Okay, I didn't calculate it exactly, but we'll say 10 feet 6 inches. So roughly you are going to get somewhere close to 58 minus 10 is 48, somewhere close to 48 feet you have to get the answer. Okay, and we'll see what this guy is going to do practically on the site. So you are getting somewhere close to 48 feet. Yeah, like I mentioned, you see what is that you are getting? 48 feet 1 inch, and this is 1.5 inch. If this was there, it was 2 inches. Okay, so we are getting 48 feet 1.5 inch, right? Yeah. So, and we also did the same thing. Like if I go back, yeah, like I mentioned, I told you are supposed to get 48, somewhere close to that. Okay, maybe this was like 10 feet 4 inches in that case, or 10 feet 4.5 inch. In that case you are going to get 48 feet 1.5 inch, right? Yeah, you can do it the same calculation. So once that is done, next what these people will do, they will put the thread, and like I mentioned, you have to do that 3 4 5 method, isn't it? Because you need to check whether the lines whatever you have put, whether they are perpendicular or not. So we have an instrument for that called as right angle. With the help of the right angle, we'll try to see whether my line, whatever grid line what I have put, whether it is at a right angle or let us say it is perpendicular to each other. So I'll show you how it is done. So this guy is tying it here. Okay, so these stones you can keep it anywhere. Okay, it is like, you see, how do you do all these things? Whenever you have any plot, let us say this is a plot what I have. Okay, this is the entire plot, and now you have planned that your building will be somewhere here, okay, this is the place where you're going to construct. Based on that, you're going to say, okay, this is my starting point. I'll place my first grid line here, second grid line here, third here, fourth and fifth. Okay, so it depends where exactly is your plot and in which area you're supposed to do the work. And why is that they've connected this thread to this thread? There is nothing like that. So this thread, whatever thread, you can see it here, this thread is your x direction grid. Okay, let us consider which is going, and this is your y direction grid. Okay, now why is that this connection has been made? Because sometimes what will happen, we have to, now right now we have done, we have kept the stone, but that's not exactly at the center to center distance. So sometimes you need to move your stone here and there so that exactly you're going to get center to center. In that case, if you move this particular stone, no, accordingly you can move this particular stone also. So that is why what we do, we try to connect this in this way. Okay, and there is no much concept in this. Only the thing is, for our easiness, we have connected the thread from here to here, so that if I move this line, no, exact alignment I am going to get. So that is why we have done it. Okay, so we'll tie it on the other side. Okay, is it done? Understood? So this was the first grid line what we have done. This was the one grid line from here to here, and next we have, sorry, yeah, from here to here, your one grid line you have, and this is another grid line. Okay, now what you're supposed to check, both these grid lines should be right angle to each other. That means both this should be 90 degree, this should be 90 degree, both the lines. Okay, so how do you check that? For that you have to check with the help of a right angle, and we'll see that how this guy is doing that. So this is called as a right angle. I'll write it here. So it is called as right angle. Okay, so with this you are going to get that 90 degree and check whether your line is perpendicular or not. It is called as right angle, and this is how you are supposed to keep it. Okay, this is the intersection, isn't it? This is the intersection of my grid. So if there is small variation, this guy will instruct the guy on the other side to move the stone here and there, so that exactly the 90 degrees. So this is how you have to keep it. So he's telling to move on the other side. Okay, see the small variation. How exactly you need to get this? Finally your line should be in this way. Now you can see this line is slowly tilted in this way, isn't it? There's a small gap in between this. So by the time he fix it, you have to get a straight, this line and this line should be perpendicular to each other, and that is the angle between them should be 90 degree. Okay, that is how it has to be done. So almost it is on the line, the slight variation is there. So this guy will move the stone here and there so that exactly the 90 degree will be formed. So now it is almost there. Yeah, now you can see almost it is perpendicular, the horizontal and the vertical line, and that's how a 90 degrees got. So this is a first criteria you are supposed to do. So once this is done, next we'll try to see how that 3 4 5 method will be applied. Okay, so yeah, so we'll see this 3 4 5 method in the next lecture, because this lecture will become a bit longer if I try to explain everything in the same lecture. So we'll see from in the next lecture from the here itself how the 3 4 5 method is done. So we'll see you back in the next lecture. Thank you.